Okay, we're doing to page 77, numbers 1 through 4. All right, so number 1 says to do the limit as x goes to 3 of x squared minus x minus 6 over x minus 3. Now, always with limits, you plug in x first, and I get 9 minus, so I'll try 9 minus 3 minus 6, which is 0, over 3 minus 3, which is 0. Okay, so I get 0 over 0, so that doesn't work. Okay, and you do not put does not exist. Okay, now, you've got two choices. One is what you learned in the beginning, where you just factor and cancel. That works fine. Or you can just use L'Hopital's, because this is an indeterminate form of 0 over 0. If you don't get an indeterminate form of 0 over 0, or infinity over infinity, you cannot use L'Hopital's, and you must factor and then cancel out, okay? But anyway, so this equals the limit. And if you're going to put an equal sign, you must write that limit. Okay, do not leave that off. All right, now do the derivative. So I get, back that up, it keeps getting blurry. 2x minus 1 minus 0 over 1. Now plug it in again. So I get 2 times 3 minus 1 over 1, which is 5. Okay, which that is the answer D. Okay, all right, number 2. It says the limit, well, I'm just going to show you on this one because I don't think I really need to do much. So it says the limit as x goes to 2 from the right. So from the right means I'm going to pick the one that is bigger than 2. So I'm coming from this one, so I'll be on this graph. Now plug it in. 5 over 2 plus 1 is 5/3, which is A. All right, this one, which of the following lines is a horizontal asymptote? Now, if you plug in infinities, you ignore everything but these. Now, this is infinity over infinity, so you use L'Hopital's. Okay, so then that's going to be the limit as x goes to infinity of, now I'm going to take the derivative, so that's 3 times 3, which is 9x squared minus 2x plus 1 over, now do this one, 6x squared plus 4. Again, that's going to be infinity over infinity, so do it again. So that equals the limit as x goes to infinity of 18x minus 2 over 12x. Again, infinity over infinity, so do L'Hopital's again. Okay, so that's going to be 18 over 12. And then finally, we can reduce that 6 goes into both of those, so we get 3 over 2. So 3/2, which is E. Now, you could also know your horizontal asymptote rules, okay, from pre-calculus, which says that if the exponents are the same, you just get a ratio of the leading coefficients if the degrees are the same. Okay, but that only works for polynomial over polynomial. Otherwise, you do have to do infinite limits, okay, or limits at infinity. Okay, all right, so now this one says find the, and I'm going to move this over so we can kind of look at both. That seems to be a better idea. Okay, so number 4 says to let f of x equal cosine of x, find the domain and range. Okay, well, really, when it says domain, I can plug in anything I want into cosine because it just goes like this. Okay, so its domain is all real numbers, but then x, that's a denominator, so x can't equal 0. So that's it. So the domain is all real numbers, x not equal to 0. Okay, and then the range is, well, that one's a little bit harder. So you got to think about cosine is between -1 and 1. So now divide by x and divide by x. Now plug in anything you want. Well, 1 over x looks like this. So its range is all real numbers except 0 again. Okay? So y is an element of all real numbers, y not equal to 0. Okay? Next is, what does it say next? Is it even, odd, or neither? So I don't think I've thoroughly explained this one, so let me go back to that. So cosine is between -1 and 1. That does not mean that this is the picture of cosine of x over x. I was just using my reasoning skills, saying, okay, well, it's between -1 and 1, so I can pretend like cosine's -1. How big can this thing get and how small can it get? I can do anything I want. I can get any number I want here, because if I plug in a small number, all right, then I get a small fraction close to 0. If I plug in a big number, plug in a big number, I would get a small number close to 0. If I plug in a big number, that's like 1 over a giant number, okay, that would give me close to 0. Now plug in a small number, like 0.25. 1 over a quarter gives you more, because, like, think about multiplying by the reciprocal, okay? So that would be a really big negative. And I could do the same with this, okay? So if I have a big negative, or I could make even a big positive by putting a negative in here. Okay, so I put in a negative fraction, flip and multiply. So it's going to push this any way I want it, okay? Thinking about, like, this is always above it. Well, if I can make this really giant, then this has to get really giant, okay? If I can make this one really small, then this has to get really small, okay? So the top one pushing it down makes this one push down. The bottom one pushing it up makes this one have to push up, okay? So that's why I did this graph here, was thinking, oh, like, this one's range. Okay, I can see I can make this anything I want. I can make it very negative, I can make it very positive, I can make it close to 0. Then I can make this anything I want, because these are both around it, and they're basically the same graph. It just -1 over x goes this way and this way. Okay, and that's actually going to lead into the sandwich theorem, which they talk about in D. All right, so now it says, is it even, odd, or neither? So f of -x equals cosine of -x over -x. Now, this is the important thing. Cosine is even, okay, which means that the negative just goes away. It doesn't affect it because it's symmetric across the y-axis. So that's just equals to cosine x, and that's -x. So that's negative cosine x over x, which that is f of x. So it's odd. So it is odd. And there's my justification also right there. Okay? All right. C says define the limit as x goes to infinity. Well, I would think that it oscillates because it goes between -1 and 1. But because you're dividing by x, it actually changes it, because it's like it changes your range to all real numbers, where it used to be -1 and 1. So don't go by that alone. You're actually going to go by, like, this idea here, okay? And this one's very, like, you're going to get a trig function and ask you to use the sandwich theorem on the AP exam, because they're easy. They expect you to know that sine and cosine are between -1 and 1, so that helps you to do the sandwich theorem. Okay, so we just say I'm going to kind of do C and D together. It really just makes most sense. So the limit... Oh, no, wait, let's start off with, okay, and let's use our words. So since -1 is less than or equal to cosine of x is less than or equal to 1, okay, then for x not equal to 0, -1 over x is less than or equal to cosine of x over x is less than or equal to 1 over x. It doesn't even matter if x is negative or positive, because if this is negative, this would become the 1 over x, see, because negative, so that would just switch this sign, and so on and so forth. So it would still end up the same, okay? All right, but we're doing an infinite limit anyway, so limit at infinity, so I only care about x is positive anyway, okay? All right, then now, so then the limit as x goes to infinity of -1 over x equals 0, and the limit as x goes to infinity of 1, let me put a negative there, so it's the left one, of 1 over x is also 0, right? So, by the sandwich, I call it the squeeze theorem, but they called it the sandwich theorem in here, so that's fine. So you get sandwiched between these two. These are both going to 0, so this has to go to 0. The limit as x goes to infinity of cosine of x over x equals 0. And there it is. That's the sandwich theorem, and it's also the limit of it.